Good morning, ladies and gentlemen, and welcome to our webinar today on the topic of innovative and effective cleaning of fresh and aged paint deposits in stainless steel pipes. The event is sponsored and presented by Harman and BCD Chemicals. My name is Detlef Sassenberg, and I will be guiding you through today's online event. In our webcast today, we will be discussing the untapped potential in the efficient cleaning and deposition of pipes and boilers. And this is a problem that many in our paint and coatings industry are surely familiar with. Before we begin, a few notes on the discussion, definitely. On the screen, you will find a box for your questions to our speakers. Please enter your questions or comments into this field at any time during the presentation. I will collect the questions so that we can discuss them with our speakers after the complete presentation and provide you with a direct answer to your questions as much as possible. So now we are ready to welcome our esteemed speakers, ladies and gentlemen. And if I see correctly, Mr. Hans-Gerd Harman should indeed be joining us very shortly. He still needs to enable his camera. There he is. Good morning. Welcome, Mr. Harman. Greetings. And then we have a second speaker on board. That means Mr. Harman is not alone today. He has brought someone else with him. This is Mr. Eskan, Dr. Eskan. He will now turn on his camera. And now there are three of us, and we are complete. Great. A very warm welcome to you all once again. And perhaps we can start a little bit with Mr. Harman, the esteemed founder and CEO of Harman Limited. Mr. Harman, if I read that correctly, you are actually a certified civil engineer. So I would say steel, mortar, concrete. What drew her to fluid mediums to engage with them, Mr. Sassenberg, as that is the general attitude of a civil engineer?
There is the infrastructure. It's about underground pipeline systems. I'm a civil engineer. My focus has been water distribution, water treatment, and water purification. And that's how I actually got into this whole industry for municipalities through my father's company, really. These are our main jobs, and what I had developed from them, that's where we have arrived today. I am happy about that. What a story.
Yes, if I see this correctly, you have made quite a development. Founded in 1997 as a two-man operation, now 25 years later, a mid-sized company with 70 employees. So, respect. There are a lot of municipalities that have relied on your expertise. Now, it's about time they enter the paint and coatings industry, I think, given what they have to offer. And today we're very excited because there's a lot of research and development going on. There is a system called Comprex, which is patented. We will certainly learn about what it is today indeed. Yes, then I would say, Mr. Harman, you are not alone today. As mentioned, we have a second speaker with us, that is Dr. Eskan. Mr. Eskan, you are a technical account manager, but that wasn't always the case. If I read correctly, you are a provieta chemist in the field of physical chemistry. Again, for us paint chemists, physical chemistry has always been a challenge. In that regard, I always have deep respect for anyone who has earned a PhD in physical chemistry. So what drew you to this topic?
So you can see I started as a commercial account manager at BCD Chemicals in 2018. At first, it was mainly about commercial matters, but over time, I had the opportunity to move more towards what I studied and what I really, really enjoy, definitely. And it just so happened that this position eventually became available and I wasn't allowed to freely express myself. And now this opportunity we had with Comprex came at just the right time in the right place. And of course, I seized it. And I'm excited to be able to present a few slides to you today.
Yes, for me, there's no question that I'm passionate about surface technology. It's always been my profession, my passion. What excites you about this topic?
I'll put it this way. For me, surface technology is kind of a paramount discipline because, in my opinion, it has different phases. And that's what makes this system more complex. But we face this problem everywhere, not just in paints and coatings, but also in other areas. And that has always excited me. The more challenging the tasks became, it awakened a kind of motivation in me, and I tried to solve them. And that is, I would say, a self-drive that continues to motivate me to this day.
You've made a lot of friends. When you say that was a master discipline, you can see all the people on the screen getting a bit bigger. So that's great. Thank you for that. The start is good, but if we now move on to your contributions, well, when I think about pipelines, if I remember correctly, a lot of European names come to mind. So Bernoulli, Venturi sounds Italian, but also Euler, Hagen, Forsoil, Prantl. And they always tormented us in technical chemistry with differential and integral calculus. And I must say it was always quite challenging. Mathematics gentlemen, they were initially dealing with laminar flow. It gets complicated when things become turbulent in the pipeline, and that seems to be the case with you, if I understand correctly. But could we also find a basis for your presentation here? I'm not sure, but I would suggest understanding the parameters of the Sinner's circle, the foundation for cleaning of industrial plants, is sufficient for today. I hope so. So chemistry, mechanics, temperature, and time, I believe that's something they focus on primarily, I hope, today. So it's constantly about mechanics, no Bernoulli, Unko, and Euler and stuff like that.
No, one could transform this a bit more to the physical level with Helmholtz instability and these turbulences, two flow streams with simulations, CFD simulations. I also have a little picture with me, but we don't want to go that far. With us, you have to feel the force. You have to see that we really get to where the deposits are.
Yes, so a topic now about paint and varnish, right? Yes, I can already see there might be a new seminar soon. Not bad. But now I would say, let's not keep the suspense any longer and we should get to their contributions. And yes, I would definitely say, absolutely, indeed, proceed. The floor is yours.
Thank you, Mr. Sartel. You're welcome. Ladies and gentlemen, I am pleased to be the first to kick off with my presentation. The topic has been sufficiently addressed by Mr. Sachsenberg. I would also like to start right away, and with that, he has almost made my first slide obsolete. I've been in the business for 25 years, and I'm present in Germany as a service provider at 3, almost 4 locations, but we are also active across Europe, from Latvia down to Portugal, and from the United Kingdom down to Italy, and even more countries. My area of expertise is indeed originally coming from my direction, the municipal field. This is about drinking water, the #1 food item, removing deposits from pipelines from the small DN80 to the large DN. We are indeed working for many, many municipalities. The wastewater pipelines over long distances for 20 years. Another area is the drinking water installations, involves cold and hot water circulation and large buildings. And for the past 15 years, the industry has approached us with its various manifold pipeline issues. And here we have a wide variety of piping systems. This includes raw water, river water, cooling lubricants in metal processing, as well as heat exchangers, plates, tube bundles, and much more. And this industry is a very large gateway that is opening more and more in terms of applications. And here the deposits are often very intense and extremely frequently recurring. For this reason, the service eventually ceases to be the first choice. And so approximately 4 years ago, we initiated the topic of plant engineering in the field to be able to respond accordingly. Hygiene is very important to us. Food is #1, but especially in drinking water installations in large buildings and clinics. The well-known keyword Legionella is certainly very relevant here, but also Pseudomonas as germs. And since these germs are only 5% plankton in the liquid, logically 95% of them are in the deposits in biofilms, which are the retreat areas. And we were able to show the removal of deposits is a crucial foundation for hygiene in such systems. Clean, perfect water can be delivered to the end customer in high quality through proper storage. Another extremely important topic for hygiene and cleanliness is our clients from the pharmaceutical industry. Over the past 4 years, we have been able to profile very complex systems with many installations for 3 very large companies, especially during the commissioning of production facilities. It is about removing chips, production residues, or deposits from production. It's really, really exciting also because the QM is pushing from behind, and we had to prove what we really know about hygiene, starting with the air. An exciting event that we might all experience at some point is endoscopy. Flexible endoscopes, that's a new area for us. We are in the process of developing our first medical product with Comprex, specifically to handle the manual pre-cleaning and brush cleaning of these small channels. And we have, and you can also read this on comprexmedical.com, we have been able to demonstrate exceptional cleaning performance with 2 dissertations here, ideal conditions for disinfection and preventing cross-contamination in children. Just to give you an idea, so we can understand better how broad the spectrum of our air-water project is. So not just with air and water, but also a little bit of love is part of what we do. And now I would like to briefly share my impressions on how we can contribute to your paint and coatings industry. And I would like to basically, it has already been mentioned a little, but the topic did significantly impact your industry in May 2020, the change in the limits regarding the addition of biocides and preservatives. Here, a strong reduction in the placebo area, I have also heard from other conversation partners. And the production of the resulting preservative-free products is indeed highly problematic because naturally the requirements for raw material quality increase even more substantially considering the ingredients already present. Consequently, operational hygiene during their production also plays a crucial role, and more. The contamination from product residues is generally the problem. Water-based paints plus temperature cause the germ count to quickly rise and residues form, which the pig cannot completely remove, or of course, in areas that cannot be pigged. And this certainly includes not only the pigging stations and the soft ones, but also the incorrect branchings and all kinds of cuttings. Removing these product residues is of course not trivial and can be very challenging. Flushing with water is therefore not necessarily suitable for this. Mr. Sassenberg mentioned laminar core flow. In the middle, the water flows quickly, and at the edge, there is lamina, the entire boundary surface, due to the capillary frame force. It concerns the time, the consumption of water, and therefore, as a consequence, a significant amount of wastewater with the associated cost developments. However, and if the product residues are not removed, then what you all know happens. They adhere, they harden, they lead to stubborn deposits, and they also provide an ideal surface for further accumulation of product residues. And the effort required for cleaning becomes enormously high, especially to ensure hygienic conditions and thoroughly clean. The result is certainly more and, above all, longer plant shutdowns. That's, in my opinion, my take on it. Cleaning will also be the task of the future. Indeed, in the near future, it will be a very tremendous challenge to keep your production facilities hygienically clean and to be able to operate them hygienically. Therefore, cleaning is not necessary at long intervals, but should actually be part of every product changeover, every batch operation, and in fact, should be done regularly and thoroughly. And the sections can also be cleverly and strategically defined and chosen so that you don't have to shut down the entire line or the whole production. Continuous cleaning is therefore also the foundation for the long-term cleanliness of your production facility. And for this reason, the logical consequence is to integrate cleaning as a fixed production step in the operation. The entire process is integrated and automated. This logically results in shorter downtimes and better utilization of the equipment. So much for that topic. These are fresh paints, newly emerging products and deposits that needed to be removed. But the main topic is the existing installations. The basic cleaning of existing systems is an important task. Removing old deposits is difficult. And here, I am pleased that someone will later be able to present you with a first-class solution approach. Now to our development, we are unrelated. We entered the paint industry unexpectedly. In 2018, we were first contacted by a very large, well-known manufacturer who found us on the internet while researching cleaning procedures. Yes, it was just a simple meeting with an introduction. It was a small test setup generated with paints that had been there for 5 days and had partially dried. We were allowed to rudimentarily present our cleaning process there. Yes, then the initial enthusiasm set in, which provided the foundation to gain some financial knowledge, to actually carry out the cleaning experiments, to explore the possibilities, and to identify the weaknesses. And we have started at our technical center in Landau, I will show you a film soon, with all possible installation parts, including pigging stations and pig diverters. We had a DNA of the nude soft tissue, a huge chunk with a full sphere, where naturally the color is cut off at the back and usually smudges around. But even here, the topic of scoring can really be demonstrated right away. Test cleanings in the production facilities followed. The questions to be answered were, what happens in long sections? What happens with risers, with overhead lines? How do the distributors behave, the branching, or can you also go through filters? And a very, very important point was, how do the different products behave, their composition, and other generated adhesion conditions? And an important point was the subsequent engineering, the consideration of how to integrate Comprex into a production facility for the first time. You can see the pictures here below, a mum's garage from below. Complex will follow shortly. We meticulously brushed it on, thoroughly soaked the pig, and completely inserted it. And here you can see the result after 5 compressions. The pigging station was indeed very neatly and absolutely thoroughly clean. We might have expected a bit of residue behind it, but everything was completely gone there too. And yes, and then the next ideas came, because appetite comes with eating. Then the idea came, let's try to make a pump. We then placed a rotary lobe pump on our small cart. Here at the back, parts of the test setup are painted. A plexiglass was screwed on top. And now I ask Mr. Schürmeyer, our esteemed colleague, to play slide 12. This particular slide is a film about the intricate process of pump cleaning. You see the film? From left to right, the water pushes. The pigments are gradually and slowly removed. A view of the pump impellers is slowly emerging, but now you will see the first complete shot. The trolley will move a bit shortly. Yes, there it is, the first one, the second one. And now we could actually stop here to save water. Mr. Schürmeyer, you can end the video now, and then I can continue with my presentation to save time. Wonderful. I will share my screen again. I hope that has worked so far. If I don't hear any objections, I'll just continue. So this pump film led us to successfully enter the first state-of-the-art and advanced production facility with an installation in the year of 2019. This led to collaborating with the client, plant constructor, engineers, signing a confidentiality agreement, putting all the cards on the table. And then a complex controller was installed in the new state-of-the-art production facility. 6 malt lines with a total of 70 sections were cleaned, all connected in series with cleaning programs that were completely and fully integrated into the production process. Communication took place via Profinet, and we now have fan maintenance. It took several iterations and a few hundred minor issues like pressure wear and so on to identify, exclude, and also to slightly adjust the fastening of the pipes slightly. But a very, very fascinating success is that even the continuously replaced non-pressurized wastewater pipe no longer needs to be replaced because it is also cleaned and very, very effectively and thoroughly maintained. So at the end of the year 2019, we were approached by Mefid AG from Bad Kreuznach. I am very glad that I can mention both myself and the company by name here. I would like to personally thank Mr. Mecker and also Dr. Grossi. It has always been a great collaboration so far. We have been able to contribute a lot to them, but we have also learned a lot. At their production site in Bad Kreuznach, we implemented the wild pigging with our service technology, determined through distribution trees and pigging recovery where small modifications were necessary. And we have also developed revised cleaning programs with service technology in order to properly and thoroughly clean the individual sections at a later stage. The entire technical leadership rule of Mecca Dagobert was with us. We reviewed the matter at the pilot plant, discussed it, and decided to build a first mobile compression unit with 300 cubic meters of air volume for Mecat AG. This element draws in air and water on the left side. Clean air, 6 bars from the operational compressor not clean enough, is sent through a quadruple triple filter battery, and thus we achieve drinking water quality combined with air quality, and it only gets cleaner. Complex at the back, touch screen. Up here the programs and operating personnel are controlled, and the entire system is indeed quite garden weak because the message owns some plants, and this device also goes a bit, let's call it signature, to achieve acceptance for Comrex in the other plants. Certainly, definitely. As soon as I interpret Dr. Gross's directive, they are also on their way to consider stationary positions. And Ducat Roth from the AG is always prepared and has delighted us once again, this time with a rather large eccentric screw pump. We couldn't even control this pump with our extremely weak power supply back then. We have now connected it here with a bidirectional complex unit, which is applied with this attractive and bright color. Yes, and brushed the bottom left, you can see the discharge ratio, and the result in the bottom center and bottom right can be seen quite well according to Parkinschuten. You can also still see the old paint, which does not come off. That's for Mepad AG. We could already share some experiences and insights with BCD Chemicals on this as well, but we might have saved that for later in the technical articles on my development. In 2020, we were approached with major projects once again from the first client. which involved a complete production setup in the new production with Conrex. Once again, extensive and intensive engineering work with the plant manufacturer and the client was necessary. How many complex stations are needed? Various installation parts had to be covered, including manual filling, which indeed initially required a lot of creative thinking from us. We have developed various things here. You can see the corresponding first 4 modules at the bottom left, 3 mount modules and 1 standalone module as we delivered them, which have now been installed and are also operational. The production facilities for such a dispersion, for dispersion farming, are of course still fully included in the program from the raw material storage once the binder mixing stations were completed. And our task with Cobrex was to clean all the pipes, all the pigging lines, valves, pump filters, and distributors as thoroughly and meticulously as possible, let's say, without any gaps. During the development process, 4 other wall modules eventually became 5 in total, along with a standalone wage module for the process overall. You are relatively familiar with the production, often in the form of these operations. We have a Richard, they have a pump, they have a mul station in the transmitter through long distances, receiver in the cooling area. For our work, we naturally need an additional piping system, which can be cleverly laid out to be used multiple times. Here on the left, you can see our stationary compressors with the fittings such as the control cabinet and the additional touchscreen. The interface to the control weapon is very important. In this case, it was initially seen as a task to communicate with Siemens as an origin task, but it worked out really well. Our subsidiary Ziklotech with Jan Walter, as mentioned in the article, was able to quickly find an interface to 7, and thus we are a part of the whole. We get the water from the left here, city water, clean drinking water. The 6 bars compressed air is sufficient for us. We just need 1 more storage tank to have enough reserve. And from that point, Comprex will start with a correspondingly short lead time. And now with these various different types of fittings, we have many options for pipe allocation and pipe cleaning. The first pile here is routed through the bypass and backwards through the filter up into the separation between air and water. With other filtration methods, of course, the cleaning of the pump definitely goes up and away, then subsequently over to the top, the softening station in the flow direction, and also the relaxation or conversely against the flow direction. And so we also move the filter back and forth. In total, we can apply 5 cleaning procedures to this production line, effectively covering everything. The automation of the process is a very important point. I just mentioned the interface. The data needs to be transferred back and forth. The control room defines the specific sections to be cleaned by the valve position and provides us with the information precisely. We take the customized cleaning programs for this specific section from our extensive database, work through the topic, and give the command back when done. This is very important. We want to have consistent, repeatable cleaning procedures, and it is a verifiable and thorough process. It is a consistently recurring quality that we must deliver to our clients and stakeholders, ensuring that the programs we develop are tailored to meet their specific needs and requirements. And this is the point. When you clean such a line with 5 steps, then there are also water quantities that, even if the water is little per cleaning, in the sum of many cleaning processes, it becomes an unpleasant addition for the sewage treatment plant. So we thought about where we can save. And here is the first term, eco-cleaning. So with 50% of half the water, we achieved about 93% of the cleaning efficiency. It is justifiable to perform eco-cleaning 5 to 8 times in a row and then do an intensive cleaning using the optimal amount of water and duration. And the third point is, it is now very practical and feasible to treat this piping system with Comprex and BCD Chemicals WBC3. MA at longer intervals, even once a week, either sequentially act on complex WBC and complex or even synchronized, ideally removing all small particles that still adhere. The last sentence already highlights a very, very interesting optimization potential indeed. We also have a partial circulation option available. I can also clean with cloudy rinse water if needed as required. I'm not interested right now whether it's clear water. So if we do 90% of the cleaning process with complex and already used water and add the last 10% with fresh water supply, then we have the same clean ratio. But we are still at the long cases. Hopefully this will also be integrated into the next processes or tasks. That was the result today, the possibilities in the paint and coatings industry. Now I would like to briefly show you the compression process. I have a short film here and I'll just go ahead and play it now. It's not that central. What do we want? We want to clean the deposits on the inner wall of the ear pipe using dynamic, rapidly changing, differently targeted fast water jets. What does it look like? Here on the schematic diagram of our Corex unit, from the left and right, water enters the air. We are currently generating the comprips here, and the acceleration pre-stage is also in place. The water plug enters the section of the pipe to be cleaned. The cleaning performance starts from the first centimeter. This image passage demonstrates that even collapsed water plugs can effectively be regenerated in the pipeline through various changes in parameters safely. The water is our cleaning agent and the air is our propellant, but the acceleration can only happen if this thing is definitely open at the back. So we need an outlet, we need an almost pressureless pipe through which we can then catapult these water plugs at high speed. We achieve up to approximately 20 m per s. The following diagram should briefly illustrate that we can indeed navigate around the bends, and many bends are not really a problem. That is, even the self-flow stabilized inner bend, for us it takes almost the most beating when the water plug sways back and forth here. This passage indicates that changes in nominal diameters are not an issue for our water pick. Also, nominal diameter expansions are typically symbolized here below for new block formation. And branches, many branches are also manageable because the point where it opens, where the energy comes out, is also where our cleaning performance goes. And this image here also represents valves that offer us no resistance. It works with flaps or cable materials. Valves can be snapped, crucially using significantly less water. We practically start with essentially zero water and then gradually increase it. Then we also have the high speeds of the water jets, 70 kilometers per hour, which is equivalent to 20 m per s, compared to an already fast water flush at 3 m per s, and the dissolving power is enormous. Here is a CFD simulation by Professor Kowalczyk from the University of Duisburg-Essen, part of a BMBF project. He simulated our test facility. Red stands for power, blue for no power. And it is very nicely illustrated and proven that we can especially get the power to where we need it, where the deposits are, whether it's paint or iron manganese deposits or other products. And we achieve a 10 to 100 times, and actually I rarely say this, but even up to several hundred times higher wall shear stress compared to these 3 meters per second. And now I would kindly like to ask Mr. Schürmeyer to please play slide 26 once again. Thank you. Here you will soon see our pilot plant, which we have in Landau. You are also welcome to visit our technical center. You can lay your hand on it. So a test setup with 50 meters of transparent plastic pipe, DN80, a high performance pump, 3.7 meters per second speed in this ER line, so a crisp water flush. We also have the capability to introduce solids into this test facility, achieving even higher abrasive forces on the pipe walls. And here at this point, you can see on the left how we can flush in metal parts. Where the monitor is, magnets are positioned from below onto the pipe, and from the outside, the binding forces are applied to the pipeline. The metal beads are fixed, used differently. Here you can see an air-water exchange, a pressureless pipe, water flows back, and a new block is forming. Different parameters, incredible dynamics, acceleration. The first two magnet groups are worn out. Changing the parameters, increasing the dynamics, brings completely different forces to the thick magnet, not to the magnet itself, but to these metal particles that adhere inside. And now you see with the last shot, another modification and away with it. And with that, we can really show what kind of forces are involved. So if Mr. Schürmeyer just hands the moderation back to me now, I have the screen again, then I can continue from here again. So I am almost at the very end of my presentation. So if I can just bring up the last slide, that is now indeed the case. With our complex process, we can offer you a market available and effective cleaning procedure in your paint and coating world that reliably and comprehensively cleans pipes, distribution filters, and pumps in various applications, regardless of geometry. Integrated into the process, the automated removal of fresh dispersion paints through these individual, but then fixed and thus suitable for a validated process, formulations ensures this effectively and efficiently in a consistent and reliable manner. We can also naturally address product changes, naturally including formulation changes. This makes it possible to create preservative-free products in a clean, hygienic production facility. It all sounds good, certainly is, but we have clear limits. Clear limits are the binding forces between the deposits and the surfaces in the pipes. And here we clearly see major problems with existing systems that have built up stubborn deposits over many years. No matter how much time we have, we can't really get rid of them. Other measures are necessary here. Similarly, for securing our process integrated complex cleaning by integrating chemicals into our pure process. And I am very, very glad that BCD Chemicals, represented by IMAM, indeed introduced us to these two mentioned customers. We have come together and have now formed a solid alliance, a cooperation between the two companies, because we want to offer these combined services to your industry. And now I would be delighted if Iman could show us what he has developed with us. Very exciting, and I am definitely very glad that we can now present a complete solution to you. Iman, your topic.
So everything should be visible now, I believe, I assume. Yes, Mr. Schulmeister, great. So a big thank you to Hans Gerhard for the wonderful introduction to the world of complex. Dear participants, I would like to take this opportunity to take the next approximately 15 minutes to provide you with a comprehensive insight into our collaborative and joint project. You are familiar with the company BCD Chemie. I see a small one. The company BCD Chemie is familiar to you after over 110 years of history in the chemical industry. You probably know us from a department in your company. We operate throughout Europe as well as on an international level and in other parts of the world. And today we are proud to say that we are at your service with 12 branches across Europe. Our company management and central product management are located in Hamburg, and we are very proud to be able to show you today that we have active customers. The trend is rising. Together, we achieved a turnover of over 200 million euros last year, and what is even more important, myself and over 100 other highly skilled and experienced chemical specialists in the field of chemistry and related areas are available to you every day to help you tackle the challenges and issues that may arise in daily business. Company BCD Chemie is an extremely innovative and multifaceted company with various divisions. One of these divisions is our surface technology, which today boasts over 40 years of expertise and experience in the field of surface treatments. Our core competencies include, among others, water-based cleaning systems, solvent-based cleaning systems, and industrial cleaners, such as, so our target markets, besides paint and coatings, automotive, aerospace, medical, and electrical engineering, include many other industries that we serve. We sell our premium products, among others, under our own brand BBC. This includes, for example, paint strippers, cleaners for dispersion paints, VOC-reduced thinners, core cleaners, hydro flushers, and so on. I can expand all these categories as much as I want, but dear participants, we know we are not here today to show you how well prepared we are in the entire industry. Today, our main focus is on the topic of cleaners for dispersion paints, which is known among our audience as water-based cleaning systems. At the beginning of November 2018, they were tasked with developing a cleaner to create a uniform and efficient standard for operational hygiene in the industry, and effective. The ultimate goal of this development was to prevent the formation of germs both in the pipes and in the boiler. Ideally, definitely avoid 100%. We took on this challenge back then and started with our lab experiments, and as it always begins, we need a starting point. For this purpose, we went to the customer who provided us with the paints accordingly. We applied these to stainless steel sheets and dried them for 48 hours at 70 degrees. Then our screening and development began. To date, we had some products in our portfolio, but we ultimately examined, prepared, and tested over 60 different mixtures based on various different alkalis and acids, as well as in combination with various different inhibitors and surfactants. Such a test takes approximately about 36 hours in total. I am a big fan of visualization, which is why I brought you a short 8 to 9 second video. Here you see the colleague in the lab, and this is the so-called friction test. This is an interior paint that was applied for 16 hours in our BBC 301, the famous Disperx. You see, the colleague moves his fingers over this paint, and he can easily remove the paint from the surface effortlessly without much effort or force. After obtaining these results, we moved forward. We said, okay, now we want to capture this scientifically. We want to understand exactly how this dissolution behavior works. Of course, we used analytical measurements to assist us with this. A turbidity test, also famous, all formazine standard, which you probably know from the drinking water sector, was conducted. Gravimetric measurements were carried out, meaning we dried a paint, placed it in the cleaner, took it out after 2 hours, dried it again, and then noted the weight loss to gain a bit more insight into how this mechanism actually works. Photometric measurements were made, such as so-called transmission measurements. We looked at what effect this solubility behavior has on our cleaners, whether we can recognize a certain mechanism repeatedly, and so on and so forth. So many analytical methods were used. I don't want to go into each method right now, but there is a diagram that I would like to present to you today, which also gives us a sense of why we chose the path that has brought us to where we are today. So this is essentially and basically a transmission diagram. You can see time in hours on the x-axis and our transmission on the y-axis. This is a dimensionless unit, and at time 0, we are at a transmission of 1.0. This means that this sheet with dried paint has not yet been placed into the solution. This is a preservative-free paint that we have incorporated into our BBC 301. And we have looked at how this transmission changes over time. If we look at the whole thing for 5 hours, we see that the transmission decreases, but this decrease is quite marginal. If we look at another 16 hours, or rather another 11 hours, at 16 hours, we see a significant decrease. We are at a value of 0.5. We continue to follow up and take a look at it. After about 20 hours, we reached 0.26. Now you ask me, what is the essence of such a diagram? What I want to show you, what I want to make you aware of, is how, as Mr. Sackenberger mentioned at the beginning, such a lysis behaves. It's not as trivial as one might think. You have dried paint, you apply cleaner, and it works. I've illustrated it a bit schematically here for all our physical chemists or paint engineers among us. You can see different phases. That means such a dissolution process is quite complex. If you actually want to examine it thoroughly, you could write several doctoral theses on it. We'll just take that with us for now. And the second point, which I can see clearly from this diagram, is that we can guide them, is that chemistry needs its time. That means to achieve a result that is satisfactory for us, we need somewhere between approximately 16 to 20 hours or so. After that, a kind of equilibrium forms. Not much changes anymore because we have movement, flow, or something similar here again. That means we have no mechanics. At this point, I would like to thank the University of Duisburg-Essen, which has supported us with many of these measurements. And now we move forward. We have indeed achieved the results in the lab, and we actually wanted to know if these results can in fact actually be simulated in the operation, if we can achieve the same results. After that, we went back to our customer. Our customer did something very nice. He cut out approximately 1 meter long pipes from the operation, cut them into small pieces and welded them. This is what we see here in this picture. This is a small piece of it. We placed it in our cleaner for 2 hours and observed whether these contaminants, which really come from the operation, show the same results as we achieved in the lab. So I have enlarged the image a bit here. It is always more difficult with webinars. However, if you look closely at the thing, you can see a certain mobilization of the individual color particles after just 2 hours. Only after about 19 hours do we see exactly the same result that we previously achieved in the lab. This means that without retrace, we have a color solution that sits well above the surface. But if they want to completely remove the paint, they need the rubbing test again. Somehow we need a certain mechanism to get rid of the loosened paint so that we have the bare metal again, somehow. Then we went ahead and then said, all right, we will indeed take a closer look at the sensory circle. Mr. Saffenberg had agreed beforehand, and ultimately the sinus circle is known to them. It states that the success of cleaning depends on various parameters, and ultimately these are exactly the 4 parameters: mechanics, chemistry, time, and temperature. The most important thing I want to take away from this is that these quantities are in exact proportion to each other and always result in the same total sum. It sounds a bit scientific at first, but please give me a little bit more time. I will take you along and show you and apply this detailed and comprehensive tooth decay cycle to our cleaning method. If you have a purely mechanical cleaning, as shown in orange right now, then you have the chemistry, then you have the temperature, and you have the time. But one gap is missing. We always have to come to the same total sum. This means that this question mark must somehow be filled again. We have different options for that. Either we can fill it with chemicals, which for us means different labeling, environmentally unfriendly conditions, or we have to fill it with time. Now, some colleagues from the audience might say, watch out, there's also temperature to consider. I'll address the topic of temperature briefly in a moment, but for now, let's set temperature aside completely. This means we can focus on time and chemistry. Similarly, if you look at the mechanical side now, it's exactly the same. That means our cake is not quite happy yet. This means we need to fill this gap either with mechanics or with time. Regarding the topic of temperature, we agreed relatively early on that from an economic perspective, considering the development of prices and energy prices in recent years, and also from an environmental perspective, it is not relevant to us at all when thinking about topics like carbon footprint, carbon reduction, and so on. Therefore, we do not want to discuss the temperature factor at all. What do we want to achieve? We want to ensure that this gap is not filled with a sense of time. We need to become faster and cleaner, and that is what we have looked into. What about the time factor? What does this time factor do in the individual cleaning methods? If they are on the chemical side, they have relatively long exposure times. If they are on the mechanical side, they can clean all fresh paints immediately, even with the most complex geometries. But as soon as the dirt starts to dry, once it is sufficiently dry, then intensive treatments are needed, and mechanical methods alone are not enough. After that, we put our heads together with the engineer from Hameln and collaboratively thought about how we can optimize our circular saw to make it more efficient. So we have actually built a test track. I mean, Hans-Gerhard already mentioned earlier, this test track that we have built here, it is indeed a PE line GN. And we didn't make it easy for ourselves, not just a straight line, but we incorporated over 40 bends to show exactly what Hans-Gerd mentioned earlier. Comprex is not afraid of dead zones. Comprex delivers the energy exactly where we want it. Exactly. The next problem we are currently seeing on the left side is foam formation from the chemical side. Try using a cleaner that contains surfactants, which will sit in motion, and you will see relatively quickly that you have a foam pad forming in no time. We need to put thought into this. We have been working on development for months in cooperation with Hameln. We conducted various tests, accordingly developed our WPC 303 and Dreieck. This is a highly effective cleaner that keeps foam formation well under control despite the impulse movement. And we didn't have to compromise on the incredibly high level of cleanliness and efficiency. Now we had a test track, we have the appropriate chemicals for it, and we said challenge accepted. Now we want to show our customers precisely what we are specifically and meticulously capable of, and what we can clean accordingly. Subsequently, the customer sent us 5 different colors that are relevant to him. You can see I have written them down and abbreviated them with individual letters for simplicity. We went a step further. We said, we won't do it with lab tests anymore. We want to understand this dissolution behavior even better. That means we didn't work with an aging condition of 48 hours at 70 degrees, but instead we dried the paints for 1 day and 6 days to see if a paint dried for 6 days dissolves differently than a paint dried for 1 day. We have conducted proper screening. What levels can we go with BBC 303 and 3AG? Where do we achieve the optimal cleaning effect? And of course, all these tests were ultimately conducted in a controlled environment at indoor temperatures of approximately 8 degrees to show that the temperature primarily does not matter to us. So now I would like to show you such a test. But first, I want to explain the setup a little bit more closely so that you can see it as well. You now see 2 stainless steel sheets on the screen, which were covered with paint. They were dried for 6 days, and then these particles were embedded into this PE surface or PE line accordingly, and then the pulse was applied. Now, I would like to briefly ask Mr. Schoenmeier to have our director play this short video that I have brought for you. This involves approximately a 20% WPC 303 and 30 with 2 bars pulse applied to these specifically mentioned contaminants. What I wanted to show you in this video is you have seen 3 pulses. You can see how much force is behind a 2-bar pulse. You see the usage within the entire line. And finally, when the camera gets closer, you can also see the foam, how well we control the foam, even with a 20% cleaner. We conducted this test until the steel sheets were 100% clean, ensuring no residue or contaminants were left behind. You can now see my wife playing the video again in parallel, demonstrating the process step by step. Well, when we conducted the whole thing in different colors, we summarized our results accordingly, and I believe this diagram speaks for itself accordingly. Ultimately, you see time indicated on the x-axis again here, but be careful, this is the most beautiful thing happening here. We are no longer in the scale of hours, but in minutes. and on the y-axis you can see the cleaning degree. So what has changed here? We can, or we are able to, eliminate up to approximately 95% of all paints that had entirely dried for up to about 6 days within nearly 180 minutes using a 2-bar pulse in combination with 20% WBC 303 and Comprix. Colleagues ask, what about facade paint? It's only at 65% after 180 minutes. Great news, we are also capable of handling facade paint. You know that once it has dried, it's very hard to get it out of the line, even to remove it. For this, we simply need more power, which our Comprix system also definitely offers. This means we are able to remove even the worst and toughest dirt with these extremely effective combinations. Now let's briefly go back to our Zinner's circle, which we saw earlier. Now all of a sudden, you might understand why we call this presentation webinars, Zinner's circle at its optimum. That means these question marks, this gap, are accordingly filled by chemistry. We recreate this circle so it is complete again. In doing so, we create something entirely new, something that has never existed before. For example, we can provide a very time-efficient method by using chemical pretreatment followed by mechanical transport to efficiently clean the respective lines. We are now achieving a cleaning performance in the time that no single cleaning method alone had ever managed, thanks to our strong chemistry and strong mechanics. We can entirely ignore the temperature accordingly. And of course, if you find this method to be effective, we can always emphasize that the highest possible efficiency is indeed achieved when you combine both chemical and mechanical cleaning, which we can offer you in the form of a stationary system from Comprix. At this point, I'm actually completely done with my moderation, or rather with my part. I would also like to share 2 extremely important slides for the companies Comprix and BCD, along with some very detailed take-home messages and the goals we have set for the future. Take your home message. This is the most important thing you can take away today. Together, we can offer you a complete solution, from simple services and basic cleanings to cleaning processes, a simultaneously operating cleaning process through chemistry and mechanics in a stationary system. They have access to all numbers through both WCD and Harman GmbH for the complex technology, and they can also use the mobile CU systems for the specific task at any time. You can now access our 3.5 years of expertise in this field at any time, and together we are now able to refurbish the old stock in the shortest possible time. And furthermore, what I find great for everyone now is that actually and indeed the production of preservative-free paints does not pose any additional or greater challenge from an operational hygiene perspective than before. Of course, we want to further intensify and strengthen this entire cooperation. This is not a simple method. It is a cleaning concept that we can envision presenting across various industries, including overcoats and paints. Everywhere where operational hygiene plays an important role, everywhere where production managers have problems with stubborn deposits. We would also like to document all the projects we have in the pipeline soon in the form of a technical article. It is also planned to hold another webinar to present new results to you. And finally, at the latest, we will definitely see each other at the in-person seminars. I have to be careful. This time it really is not a webinar, indeed. Thank God, now that the corona is more or less over for a bit at the Association of Engineers and Paint Factory in Q 2022 slightly. At this point, I would like to sincerely thank you for your attention and your kind attention, and ask Mr. Schurmeier and Mr. Hamann to kindly enable the discussion so that we can thoroughly answer your questions.
Wonderful. Thank you very much for your attention from my side as well. We are now available for questions and certainly for personal conversations to discuss everything in detail. Mr. Sassenberg.
Yes, they found it 2 years ago, I guess, and it seems very meaningful from what I have heard and seen. And in this regard, thank you very much for your presentation. That was quite impressive. And for me, these are new dimensions that you have opened up for cleaning performance in the paint and coatings industry. And obviously, I wasn't the only one who felt that way. We also have questions from the audience, and we can now address those questions. One question is, how should the cleaning fluid be collected and disposed of? That would be a question here.
Yes, that question is for me. We need decompression at the endpoint, which of course must be done either through a cyclone separator or other separation options to handle the free expanding air or gas, which could also be nitrogen. If operating in certain areas, the water then falls down and needs to be treated. When we circulate it, we use appropriate pump technology. but the separation is actually relatively simple because the air rises, the water falls, the motor drops and tip are removed, and the disposal is more attractive. Just as rinse waters have been disposed of, it can be minimized or done with a reduced amount. Thus, it can also go through the treatment plants. But these are arguments that you can get by with less. And now, regarding the optimization potential I mentioned earlier, there will probably be some adjustments that can be made in the right direction.
That means we stay within the company's disposal system. That's right.
And maybe one more point. I mean, since comparatively little water is actually required, one might also come to take into consideration, although this is still under debate, that at the beginning of the production process with water-based paints, part of the water, the liquid, can be retained to later use it for cleaning the product line and then put it back into the container where the mixture will find the right concentration again. This might seem a bit cooler at first glance, but why not?
All right then. What certainly has concerned many people is whether the pressure pulse can cause damage to the equipment, such as valves, seals, etc. Does it lead to damage? Can it cause damage?
I have to say this is the recurring question from you. Where there is lifting, there will be late falls. If I am in an old hospital with pitting corrosion, damaged old parts and everything, then a defect is also possible. But in systems like PN or PN16 that are pressure tested, we always have an open end at the back. We need a pressureless or almost pressureless line. We come in from the back with a 0.2 bars flow rate, so no pressure in the incline. Otherwise, we couldn't achieve this expansion. The only place where force is naturally released is at bends, where the change in direction occurs. The vector force wants to go straight, but the liquid has to go around. These forces naturally need to be absorbed. If you actually only have a product assembly line hanging on the threaded metal rod, such as the rain weight section, then the lines are going to naturally sway, like an appendage at the very end.
In the paint industry, there are only excellent facilities. I'm sure of that. Thank you, No. Well, what has also been frequently asked about is the complex solvent, that is ATEX, meaning protected plant technology. Do you have any idea if we can also perhaps maybe possibly align or equip this in the ATEX version? Is that possible?
Yes, that's possible, although we haven't really implemented it yet. It's also a question of pricing, but of course, by distancing from the actual control technology generated by Corvo Comprex, with a supply line, you can also check these unfavorable distances. We also work in fertilizer production, where there is a certain distance to certain areas that you do not stand behind. Outside of these areas, there is a clear yes. It involves circuit technology, control cabinets, and valve technology. But of course, this explosion-proof technology will come at a significantly higher price.
Yes, we have one more additional question for Mr. Esken, specifically about the one where you specifically demonstrated or presented the performance of the various different paint systems, such as those that were made available to you. There was a question about exterior facade paints and 180 minutes, and there is a question of understanding with additional details about it. Does that mean that the solution remains in the line for 180 minutes, or perhaps how is it?
Exactly. So that means we actually conducted this pulse, which you saw earlier, for 180 minutes. That means this pulsing takes approximately about 3 hours or so until we have the plates completely free from it. Such a cleaning process for this area would take about 3 hours if we use this parameter with 2 bars and a 20% solution.
Mr. Sattenberg, I would also like to add that this is truly optimal when done together, when WBC 303 and Drag are charged with Comprex and shot through this charge in a highly dynamic manner. However, this is only responsible if the systems are already equipped with stationary Comprex, because otherwise, with variable technology, hose connections, and mobile technology, it is excluded. If there is even a slight leak, then life, limb, and eyesight are at risk. We do not do that. If that is necessary, we have to do it sequentially. It gets complex, the product comes in, it becomes one, needs a much longer single-use time, only with circulation. In the end, it goes out and gets recompressed, the things come down. So with stationary technology, otherwise to be connected in series.
All right, I think this question has been sufficiently explained. Sorry, Mr. Eskan.
No, in this case, it was essentially for the stationary technology needs because we are going through this process together with medium chemistry.
Okay, I have another question. I saw the thing with the pump. When I see the travel pump so bare, gravity always comes to mind. Is that a problem with the complex process?
No, cavitation is not our topic. Although we have high accelerations, the force does not last long and it is far from reaching cavitation levels. We know this from our work when we're in the drinking water network. Cavitation occurs when I close a valve. On one side, I have 5 addresses printing, and on the other, nothing. And then there is a cavitation effect in a barrel-mounted valve in the tactic. But it didn't hit us in a block with 10-15. You don't go in with full force right away, slightly.
Well, from my experience, practical experience additionally indeed also encompasses compatibilities. Are there any research from the BCD regarding the compatibilities for paint systems?
Yes. Do you mean compatibility and material compatibility of the seal? Yes. So we have...
No. I mean, if they run material through the line again after cleaning, are there any incompatibilities that show up later in the coating, in the film formation, or similar situations? No, or anything else?
So this is exactly what demonstrates our strength. We can flush everything through with the chemistry, but we are able to completely remove all the chemistry from the line with 1 or 2 pulses using minimal amounts of water once the entire line has been cleaned. Because the cleaner has a basic pH value, we can always verify whether or not there is still any cleaner present in the solution, in the line, in the solution.
If that's the case, the question of compatibility is irrelevant. Good.
What is also interesting, and if I may add here, is that with Complex, I must say we can absolutely remove the used chemicals without any residue in any way. We also have this in other areas where it involves cooling systems and cooling machines. All of it is a chemical cleaning, sometimes in combination. But it is absolutely important that we simply and thoroughly remove all the reactivity of the products from all surfaces, from the seals and from the sensors. That is water and air, and it can also be another product where the viscosity doesn't significantly worsen as it does with water.
It works well there too, in fact, because compatibility is always an issue that actually keeps you busy. Indeed, definitely. That's just how it is. But if that's not the case, wonderful. They mentioned product changes. Is there any quantification of how much product changes can be improved with this technology?
So when you mention cleanliness, what we currently do between product changes is, I believe, 8 minutes for the eco cleaning and 16 minutes for the intensive cleaning. So it goes relatively quickly. It always depends on the desired cleaning performance. Maybe occasionally it will be blown dry at the back when the weekend approaches. That's how it has been done. But the goal is to get the products out in such a way that the next product really goes through clean lines. And this is the case with agriculture, herbicides, pesticides, and in particular with other products where separation must be very strict, and other similar products.
It's good to know that we also have an increase in efficiency with such an investment when it comes to product changeovers. And then I had another thought. Could this perhaps somehow in some way be transferred to color changes? That means there are many industries that have quick color changes in the application of their products. Can you imagine ever being there? Or is it an idea that we could say we can also use this system to achieve quick color changes?
I can imagine that. Well, of course, it's all trial and error. We need to test it. We can't say that in advance. We have very clear indications that this will work. Nowadays, we also meet with the major plant manufacturer who is exactly in this food sector and produces correct products without cross-contamination and without a large amount that needs to be discarded, even from a pipe filled with red ketchup. It is different. If one has a playful approach and the benefit, we naturally minimize and optimize. Here we see many possibilities, but because they are different industries or pose different tasks, we need to start best with free providers and BCD.
Yes, that's always the nice thing. When there's such an interesting presentation, all the engineers start getting all sorts of crazy ideas, different ideas, and they think about it for themselves, think it further, and maybe someone else will think it further for them, and they might find another field for their application, which could also be quite obvious to me. So now I see that the questions are exhausted. We are actually completely done with the questions, although there is one specific question that requires direct communication with you. All your questions, dear participants, have been very much carefully noted. They will not be lost and will be answered in due time. I can absolutely assure you of that, indeed. Yes, then I can first say thank you very much for your participation and thank you very much for your presentation. And Mr. Hermann Erskine, we are here in Hanover at Vinzenz Network GmbH Paint and Coatings. We are broadcasting from Hanover, and Hanover is the world capital of shooting festivals. The motto "I want to say goodbye" fits them quite well. I wish you great success, many thanks, and best of luck moving forward. We look forward to possibly new webinars on the topic if you have new ideas and developments. Yes, then many thanks to everyone. Thanks for participating. We wish you all the best. Take care of yourself and stay healthy. Goodbye from Fabian Lack. All the best to you. Goodbye. Thank you very much.
Goodbye, bye-bye.